That is only for if you have problems, if you have questions, or if you want to show something extra. Otherwise, most some people show up. Some, I guess they also a lot of you already uploaded your lab reports. Let's see. Okay, not a lot of people. Oh, so majority actually. I have 1, 2, 3, 5. 5 of you already uploaded your lab report. So if you don't have questions, there's you don't have to. Is there a MET meeting this afternoon?
Yeah, we're going to La Mesa to have dinner at 5.
Oh yeah, okay. So have a good time. Huh? So today we will just go through the syllabus, go through our material and do a brief review for our final exam. So let me share the, okay, still the web browser. So the if you look at the syllabus, those are the chapters we plan to cover this semester. And we covered an extra chapter that we should check, which is a step promoter. That's extra material, will not be on the final exam. So if you look at those chapters, we have the first half is all theory. So if you look at the first half up to chapter 7, it's about the theory, how we can analyze electrical circuits, more importantly, AC circuit in theory. The theory is very nice, actually also very simple. We don't have need to be overcomplicated. It's a simple theory. The key of that theory, if you remember, is the KCL and the KVL. So once we got the KCL and the KVL, we can apply that KCL and KVL to any circuits, including AC circuits. And by applying them, we can create a bunch of equations. How many equations we can create? Depend on the circuit. Generally, we want to convert enough circuits, enough equations to get the problem solved. For example, if I say, if I only have one unknown, so I only need one equation, right? That's just mathematics, algebra. So if I have 2 unknown quantities, like 2 voltage, I want to figure out 2 unknown, then I have to have 2 equations, minimum 2 equations. So the key for theoretically solve any circuit is look at the circuits, apply KCL, KVL, also Ohm's law, create enough equations so we can solve the math problem. So that's for the DC analysis, the equations we created are all simple equations. But for AC circuit, unfortunately, the equations we created involve differentiations and integrations. Why? because we have capacitors and inductors. Those capacitors and inductors are reactive device. By reactive means the voltage and the current are not simple relations. They have integrations, and so that means the bunch of equations we can create it directly if we analyze AC circuit will be differential equations. We call that the ordinary differential equation. So we have an ordinary differential equation which can be solved mathematically, no problem. The mathematicians 100 years ago, 200 years ago, they did a lot of thinking. They actually figured out a way to solve differential equations. So obviously we can solve directly, but it's no guarantee. Some of the differential equation we still cannot solve directly. So there's no guarantee, even though we can solve it, it's so complicated. As engineers, we always want to find a simple, easy way to solve a problem. So what is the simple, easy way? We invented the simple, easy way we invented, if you remember. Hope everybody remember. Is called phasors. So instead of having differential equation, we represent, we only trying to solve a small subset of problem. That is, what if all the power supplies are sine? So, and all the frequencies are identical, 60 Hertz, sine everywhere. And that is actually a very good assumption for the modern electrical power grid. Everywhere we have a sine, all the power supplies, no matter where you plug in. You can plug into a bathroom, basement. Everywhere you plug in is a 60 Hertz sine. So that, under that particular assumption, we can simplify those ordinary differential equations. Became just simple algebraic equations. If we introduce a concept called phasor and impedance. So put it this way, the 3 chapters, what I just summarized is the key, is the main, is the key component of that theoretical analysis. So we use the phasor to represent voltage and current. And we use the impedance to represent various components. For example, this motor. Instead of we say we have a motor, we don't say we have a motor. What we say we have a impedance. impedance. The impedance is represented again as a complex number. So this motor is represented as a complex number. And then we will plug into power. When we plug into power, we use a complex number to represent power. And then we calculate the current. The current will be another complex number that's called phasors, current phasor, voltage phasor, and impedance. So everything is simplified mathematically. And again, after that, instead of solving a differential equation, we just solve a linear equation. So a linear equation, mathematically, it's so simple. So that's the theoretical part. The second part of theoretical part is talking about power. Power is obviously very important because you pay your bill based on how much power, your power consumption. So we want to track in power. When the utility company, design their network, they want to deliver maximum amount of power. So they want to study power. And in the case of AC circuit, In the case of DC, power is very simple. It's voltage multiplied current. How about AC? AC, again, same thing, voltage multiplied current. The only difference is in AC, voltage current can be positive and negatives. So voltage can be positive and negative, current can be positive, negative. So when you multiply voltage and current, how many combinations you have? 4, right? You have a positive multiply positive, positive multiply negative, negative multiply positive, negative multiply negative. So all of a sudden, the power became can either positive or negative, because when you multiply negative to negative, you get positive. But if you multiply positive with negative, you get negative. So that is that means the power is also sign. The power is also sign. And the sign can be 50-50, 50 positive, 50 negative. That means there's no power consumption. All the power delivered will be returned back to the power supply. 50-50. If the power consumption is but the majority is not 50-50. The majority of appliances, the power is not 50-50. Instead, it's something like this. The power will be the power looks like this. The negative, you have more positive than negative, so the difference will be the power consumption. So you have a negative power. Those negative power are called reactive power. The power you consumed are called real power, like the real power delivered. And the total power is called the apparent power. So now all of a sudden, instead of one power, we have 3 powers. So we got 3 powers. So that's an active power, reactive power, and apparent power. So we use SPQ. SPQ. So P is the real power. Q is active. P is the active power. Q is the reactive power. S is the apparent power. So we got 3 different types of power. And we like to calculate each. And these 3 power actually forms is related. They are not independent of each other, those 3 powers. These 3 powers are related. We just call it a power triangle. So that's so with that, that's the first half. So we got the genetic way to analyze a circuit. We also got 3 powers. So with all those theory, what does it mean? It means we can use computers to actually analyze our circuits. So we did a couple of labs. I hope everybody still remember that website called MET322. You don't have to use MET322. There are dozens of other programs, but MET322 is the most user-friendly. As far as I know, there might be others very good. I don't know, but as far as I know, MET322 is very user-friendly. So what I highly recommend is if you are designing any circuits, or in your daily life, you met with a circuit you're trying to analyze at work or at home, you see a circuit you're trying to analyze, instead of just do the mathematical analysis, just use MET322. So MET322 is a perfect tool to simulate your circuits, to analyze your circuits, both ways. So if you saw a circuit with inductors, capacitors, power supplies, resistors, light bulbs, whatever component, you just put it, draw that circuit on MET322 and simulate that circuit. And the result, you can measure all the results. That result will be the represent what actually really will happen in that circuit. So you don't have, all you need to understand the theory, but in practice, you may not ever need to use that theory mathematically to calculate so all the engineers, instead of using manually solving a circuit, nobody do it. Everybody use computers. So multi-sim. So that's the first half, a theory, and in practice, once you understand the theory, in practice, you just use computers to analyze the circuit, whatever circuit. I think we did a couple of circuits. For example, we did a buck converter, if you remember, buck converter. We also did the voltage doubler, if you remember. We also did we did a few, maybe 7 different circuits. So that's the first half. First half is all about theory. The second half is all about the applications because this is an engineer technology program. Everything we want to talk about will be, should be practical. So second half will all practical. We started with, we actually covered 3 very important practical machines. Started with a transformer, we then followed by induction machine, and then followed by an alternator, which is an AC generator. So those 3 are all the most commonly used machines. So start with a transformer. We didn't cover the complicated issues about transformer. We just talk about the ideal transformer. The ideal transformer is doesn't exist obviously in real world. In real world, you never have ideal, but like one professor says, no model is perfect, but they are good enough, right? So mathematical models, as long as good enough means if the result is within 5% of the real scenario, so that will be a good mathematical model. So the ideal transformer is a good mathematical model for the real transformer because the differences is about 5% error. The error is within, for example, 5%. So that's a transformer. And then we talk about induction motors. Induction motor is extremely important. Everybody has dozens inside your house. And also in the industry, induction motors are probably the main main force for industrial revolution is the induction motors. It is still today. Today, if you have a field trip, we have a graduate work at the BI. He actually maintained electronics in that company, the pharmaceutical company. And one assembly line, not assembly, one production line, they have dozens of induction machines, induction motors on that production line, just to drive the material, just to push the material. So it is still today most important machine, induction. And with the last machine we covered is the generator, AC generator. We call synchronous generator because the rotor directly synchronized with the frequencies of AC we generated. So if you want to generate 60 hertz, the rotor have to rotate the 60s, multiples of 60s. For example, 1,800 RPM. If it's a 4-pole, it depends on number of poles. So if it's a 2-pole alternator, RPM have to be 300 3600 if it's 2-pole. So I have 2 generators. I checked they are both 2-poles. So the gas engine have to drive that alternator 3600 RPM to generate 60 Hertz psi. If I have a 4-pole generator, alternator, 4-pole alternator, then I only need a half the RPM. So my gas engine only need to run 1800 RPM. So that's all. That's about it. The whole semester, half theory, half practical information, and to keep the textbook, because unless you keep the textbook, unless you don't want to suffer anymore, right? It's keep the book because we're going to use the same book on 422. We will cover probably 12 chapters on 422. In this 322, we covered 8 chapters. So 422, we almost covered the remaining chapters, except a couple. This same textbook is actually used by many other engineering schools as a 2-semester textbook too. So that's about the summary for the course. Again, the final exam will be posted this weekend. It will be opened up Monday, Tuesday, and Wednesday. And 2-hour exam you can do anytime you want to do it. Just do it before the deadline. The deadline I will probably set it at the midnight Wednesday or midnight Thursday. I haven't decided. I have to check my final grade due date. I have to give myself a little bit of a time for put the grade together. So I'll give you at least 3 days to work on the final exam. It's an open book. It's a comprehensive, so that means they cover all 7 chapters. So we have 7 chapters covered right there. It will cover all 7 chapters. The format will be identical to the midterm. Also, I think everybody, at least 2 of you are graduating. I already saw your exit exam, so thank you for finishing the exit exam. Also, you need to do the exit survey. If you haven't do so, just print it out, fill the exit survey, and drop it at our department office. That is also a required procedure for graduation, exit survey. So that's pretty much all I have. So for today.
When are you planning to have the final up?
This weekend, I will most likely Sunday. At the latest will be Sunday. If I'm doing this one, the first one, I have at least 3 final exams to prepare. So I cannot guarantee, but I will guarantee midnight Sunday, I will put it there.
Okay.
This one may be a little early or a little late, depending on if it's the first one I'm working on it or the last one.
Okay.
Depend on how difficult I felt to prepare. I will probably start with the easy ones.
Gotcha.
So hopefully this is the easy one. I will put it maybe Saturday. Yeah. As long as I finished, I will open it. I will not. I will try to give you time as much time to work on the final exam. The only limit is 2 hours.
Okay.
Yeah.
Does it need to be due by a certain day?
Yeah, it's need to be due tentatively midnight Wednesday. It may be
Okay.
midnight Thursday. Yeah.
Sounds good.
You're gonna have about the same number of questions.
I will double up that midterm. Yeah. Double because we have double the amount of information covered. Midterm is a half, final exam is 100%, all the chapters.
Well, you never did put the midterm up, so I don't know exactly which ones I missed on it.
Excellent.
We never
point.
could go back and look at. I couldn't go back and look at it anyway.
Excellent
Yeah,
point.
I couldn't either.
I will study that. I will open up that so you can study. Okay, thank you for that. Yeah, that's a good point. And a fair requirement. Yes, I will investigate to how to get that midterm as
Because
one.
I thought this one was only going to be the last 3 chapters because you never let us look at the midterm to study it to see what we missed, you know, how we fared.
So I can do both. What do you guys think? You want to only test the new materials or test the whole?
Well, I don't mind either way. I just would like to see my midterm at least to, you know, because I know I missed several, but I don't know which ones they were.
Yes, good point.
And if we need to prep for that kind of stuff for the final, it would be good to have our midterm.
Yeah, honestly, I have no answers. I don't know how to do it. I have to investigate how to let you guys see the midterm. That's since we brought it up. How about the? It's a small class, so I will accommodate. I will just do the new material for this final.
Sounds good
If
to
I'm
me.
unable to, figure out a way to get that midterm result back to you, yeah. Yeah, that's something I haven't think of.
Okay. I mean,
I
it's
probably
your
can-
class. You run the
send
show.
I'll send out the email.
But I would hate to miss the same questions I did on the first part, on the second part.
I completely understand. You don't want to double dip. You don't want to
Yeah, right.
double loss. Yeah, I agree. Because the chances are the similar problem will appear if I do a comprehensive, yeah. So how about I get back to you with an email probably after the class, because I don't have an answer directly. I have to look at the canvas to see how to do about it.
Okay.
Yeah, this there's the most difficult part for me for this online teaching is feedback. I always fancy I will have another monitor, which will be the exact same thing you guys see on your computer. That will be an instant feedback, because when I'm looking back on my recordings, sometimes what I see on my computer is not what you see on your computer. That's a big problem, and I don't even know after the class. I only know figure.
Yeah, I know sometimes you'll be talking and you're like, and if you look at the number of polls and look at this and look at that, and I'm sitting there going, so I got the book out. I'm trying to follow you in the book because you
It
be
happens.
showing
It happens.
your desk or something. I don't know what you're looking at. I don't know.
Yeah, it does happen. It happens more often last semester. And but it will be super helpful for the instructors if you're using Zoom as a teaching tool. Super helpful for instructors have this identical screen the student has. And the instant feedback is very important because in a person-person same classroom, you got the instant feedback. And so open up your camera is a little bit of a help because sometimes I'm talking like everybody is like, oh, that's I know maybe I need something wrong. But yeah, again, like the midterm, if a paper version, I've just returned the paper to you. But this time I have to so I probably just test the new materials. If something happens, I cannot get that midterm back to you today. All right, any other comments? That's a good comment.
Now, I haven't sent my lab to you yet either. I've got it all ready. I just haven't sent it in. I was wanting to know about the number 3. You said that was optional, extra credit, whatever. Once we send this in, because I have the first 2 done, I was thinking about doing the 3rd one. That's why I haven't sent it. Can you resubmit more, or once you submit the 2, then it's over?
You should be able to resubmit so long as it's before the due date. I've already submitted mine and it gives me the option of a new attempt.
Oh, really? Okay. Thanks, Logan.
Thank you. Yeah. Even though it's after the due date, you can send me an email. Say, hey, I did extra. I always, want to know, how. Yeah, even after the due date. That induction asynchronous generator is a good exercise. If you have the resources, you can build a real backyard generator that way. Just like the YouTube video did. Yeah, I think Michael, you got working on electronics. Yeah. You may know more about the practical electronics than me. So yeah.
I have 3 1-horse motors that I was going to hook up to a transformer. I was just going to go all out, just kind of real big and just do something real elaborate. But I just really haven't decided how I want to do it and exactly what I want to do yet. But
Is that a 3-phase?
I have until this evening to get it done. I have it all set out in the garage and everything. So I don't know. I might just go ahead and do it. And then again, I don't know. I got to work tonight too, so I might not. I don't know. But like you said, after the due date, whether I get credit or not, I'm still thinking about doing it. And maybe this weekend I'll send it to you. Whether I get credit or not doesn't matter. But when you want to do something, you just want to do it just because you can.
Yes, even after the class, make a YouTube video and post it on YouTube. Teach somebody else. All those YouTube videos I showed is like guys like Yeah, you and me. Yeah. When you do something, you can do a YouTube video. Last time I checked, you can get $5 per 1,000 view. So if you get 1 million views, that is $5,000. That's like one, yeah, maybe.
Every little bit helps.
Yes. So $5 per 1,000 clicks. Anyway, it's a good thing to get the knowledge and use it everyday life. Is that motor 3-phase or single phase? Your 1-horse motor?
I have their 3-phase. That's why I was waiting for the capacitor to show up. I had a 2 million microfarad capacitor coming from Best Buy, but it didn't show up. It was supposed to be here yesterday, and it didn't show up. And now they're saying it might be May 4th or May 5th before it gets here. I got one coming from Amazon. For some reason, it's stuck in Illinois somewhere at one of their facilities. It just didn't pan out for me the way I wanted it to. So I was kind of hoping it'd show up here in a little bit. That's what's holding me up, really, just waiting on that capacitor, because they're 3-phase motors, and I need that capacitor for the 3-phase motor to use a 120. So that's what the holdup was.
Yeah, did you buy 3? You have to.
Well, actually, at work, they were throwing them out, and got a pass to take motors. There was nothing wrong with them. It was just over a certain amount of time, they change them out. So, and then they throw them away because they're not worth rewinding, in their opinion. So they just trash them. So I always ask, hey, can I have it? I know it still works. So yeah, I was just going to use 120 on them, get the capacitor where that hooked up. I got also a power supply that goes from 120, changes it 24 DC. It's solar. I guess you could say inverter, but basically 120 to 24 volt DC. I was going to run some kind of motors. Yeah, I had it going, but the capacitors never showed up, and I can't 3-phase it from my house. I mean, I guess I could, but that's a lot more work. So.
Well, where do you work, Michael? I need to drive over a couple of times to get some goodies you throw away. I need a 3-phase motor. I never had a 3-phase motor.
Never had
always
one?
wanted a 3-phase motor. I need to drive by.
I got one if you want it. I mean, just send me your address. I'll bring it over. Not a problem, because one of them I hooked up to a bench grinder, and I got it running with a belt. And it's an old like 1942 style grinder that my grandfather had. So I hooked it up, and I got the other 2 that I was going to use for the experiment, and they're really brand new, little rust on the shaft. Yeah. But other than that, there's nothing wrong with them. Got them wired up, as far as low voltage, you can always take the wires apart and, hook them up, 7/6 and how they, 7, I can't remember right off the top of my head, but how you can wire it up to high voltage. Has diagram right on it, so it's no big deal.
Okay.
So yeah, I've got them wired for low voltage right now.
So wired for low voltage will be the delta. Wired high voltage will be the Y.
Let's see. 1, 2, 1, 2, and 3 go to 9, 8, and 7, and 4, 5, and 6 all go together.
Okay.
That I remember.
Okay.
So
Yeah, there's a lot of practical information, practical knowledge. Yeah, you work in that industry, you know a lot real practical information, which I never did. I never did. Anyway, that's good. Yeah, just be careful, Michael. Working on those high voltage, high current, also high power motors. Just be careful.
Been doing it a while.
I had a question real quick.
Mhm.
Sure.
So what if you tried to make I don't know, this just came to me and this would probably not be efficient at all. Like what would happen, Dr. Zhang, if you made one rotor on a motor and then had a rotor within that rotor? So you have two rotors that are spinning independent of each other, but all within the same motor. Or would that even work?
So two independent rotor inside one motor?
Yeah, so like one rotor is just a shell outside of the other rotor, but you have a winding and then a secondary winding within that one. I don't know if that would just not work and burn up or whatever, or if that would do anything at all.
This sounds like a new Tesla motor you're going to invent.
Maybe, I don't know.
Two
It's just
rotors
an
inside of
idea
one
I came
motor.
up with.
That's a great idea to investigate. Or maybe
Yeah, well,
that's
maybe I can machine some parts and try it out.
yeah. Two rotors. A lot of generators have two rotors.
Oh, they do.
Yeah, one rotor is called exciter. It will
Mhm.
self-excite to create energy for the magnetic field. So you have two rotors, left and right. A bigger one and the smaller one is called the exciters.
Okay.
The way you talking, I was thinking they are a smaller one and an outer one and an inner one, right?
Yes.
I never saw that kind of design. The only thing I saw is the two side by side, a bigger one, a smaller one. The smaller one generally are used to both to generate power, but smaller one only generate power to make a magnetic field. The bigger one will generate power to your house. Yeah, that's interesting. You have two. You might figure out a way to become a millionaire, Greg.
Maybe.
This energy industry, yes, a lot of money involved. So that's why every kind of research and study, a lot of people did everything possible. I haven't heard about that inner outer rotor idea. It depends on the rotating directions. If both inner and outer rotate the same direction, synchronously or asynchronously, yeah, they are different. Or they rotate reverse, that's even more difference. The power flow will be hugely different.
Yeah.
I'm thinking mathematically I can analyze those, but whether or not it has a real world application, I'm not sure. Yeah, maybe there is a huge application nobody discovered yet. Yeah, you can have two rotors. They can rotate, independent. The energy flow will be interesting, but whether or not there's a real world application for that, I don't know. Yeah.
Yeah, like I don't know. I don't know if it would work. Or if I would just try to build something like this and I would just start a fire or something and hopefully not.
starting a fire is that's one way to I heard Edison tried like 999 times, something like that. So he started fire 998 times. The last time the fire stops and he became a millionaire.
Yeah.
Yeah, those are the good old times because the inventions generally do not need $1 billion support. Today, what kind of invention, you always need that $1 billion support behind you. Yeah, unless it's like the internet, sometimes internet idea don't, but otherwise, and also you need 100 people working together.
Mm-hmm.
All those one guy, Edison type of invention are all invented.
Yeah.
Well, Craig, I will tell you this. I worked for Pratt & Whitney for 2 years. They make airplane motors.
Mhm.
And
Okay.
while I was there, they came up with the gearbox turbo motor, which is, if you look it up, it's going to start saving the industry millions of dollars. No one used that. They used the turbine engines for years and years and years. The F-100, all these planes used the same engine. They just modified, just kept making it a little bit more of this, a little bit more, a little bit. And then someone come up with a totally different idea. And it's supposed to save billions of gallons in gasoline to do the same job the turbine engine can do.
Yeah.
So you can look it up for yourself. I'm not telling you a lie. It was all because one person said, why do we keep modifying the same thing? Why can't we do something a little bit different?
Yeah.
So don't stop thinking and don't cut yourself down. If you got an idea, I'm just saying, whether you become a millionaire like the teacher says or not, that's not the point. The point is, can you make this place better? That's the whole point.
Yeah.
Or to me, that's the whole point of me being here is, can I make it better? When I show up to a new facility, I always ask myself, what am I bringing to the table? Can I make this place any better?
Mm-hmm.
If you can come up with a double rotor motor, I mean, it already has a ring to it. A double rotor motor.
Double rotor motor, yes.
So don't
Yeah,
think
Michael, I agree with you.
You can, until like Edison proved he couldn't 900 times, Sure you can, until you see, well, no, I can't. I don't know, just saying.
Yeah. It might be worth trying out. Whether it works or not is, uncertain, but I could say it'd be worth testing it out and trying to build something. It cost me a little bit to make.
I agree. That is what makes America great. America is so great because all these adventures, people had all these ideas past 100, 200 years.
Yeah. Well, I don't know. I still haven't heard back about my plastic yet. That was something I was hoping to hear more about after I gave that presentation.
Mm-hmm.
You remember?
Yeah, I saw your presentation.
I'm not good at presenting.
It's pretty good. The only thing is I hope I can switch rooms easier, because whenever I left the room, my Zoom will not allow me to go to any other rooms. I don't know
Really?
why. Because I was in your Zoom room. I was thinking about to go to another room and go to another room, but I am unable to do it. It's Zoom basically give me some errors.
Yeah.
Because I was started with a web browser, go to the Zoom meeting, and then second time I do it, trying to do it, it won't allow me to do it. But I was there to saw your presentation a little bit. Yeah.
Yeah. Well, I had some. There was one of the scientists there said that he finds the material really interesting, and they might look into it more. So hopefully,
Yeah.
because I'm not a chemist, I don't know why the material was as tough as it was, but I know the mixture that I needed to do to make this stuff. So, you know.
Yes. Very good. Yeah, my favorite hobby is figure out how things work. Yeah, that's like okay. I hope you guys keep your lifelong learning. It's a lifelong journey, learning and successful.
Awesome. Thank you.
Thank you. Thank you. I will see you guys in fall.